All right, so describing infinite limits numerically, start with this idea again. Infinite limits are not limits at infinity. People get that screwed up all the time, and it causes a ton of confusion. Infinite limits is when you approach an x value and the height of the function goes towards positive infinity, goes super, super high, or it goes towards negative infinity, which is super, super low. So let's take a look at this numerically, and I think the way I'll do it, if you don't mind, is this way. I'm using a CAS calculator, Ti-npsire CAS. Now this one happens to be a CX version. Okay. Okay, so insert calculator, please. So go to your calculator, and let's just create a function. Let's set a control division. And we're going to use the same function we used in the last video, which was 1 over x minus 1, just like I promised that we would. And then I'm going to hit control store, and if you don't mind, I'm going to name that f of x. So f of x, sorry, not very impressive, right? But let's do this really quickly just so we can see this thing. Let's go to calculus, let's go to limit, let's go to limit as x. So I'm going to get back to the key. Limit as x approaches 1. But now look at this for a second. If we do it, if we go here and we put a negative sign here, this says the limit. Well, let's put this in here. F of x, f of x. Okay. This says what is the limit of f of x as x approaches 1, and this negative sign. Remember, it's not negative 1, but from numbers values less than 1, but close to 1, right? So if we get really, really close to 1, but we go from values less than 1, so we get, and I'll show you that in a second. Let's see what the limit would be. The limit is negative infinity. So all I want to do now is kind of prove that a little bit. We know that we can't take f of 1, so let's try it just to be sure. So here's f of 1, and it says it's undefined, and we knew that. And then, but we said we were going to take values less. So let's do this. Let's take f of. Let's take some number that's pretty close to 1 but less. Let's take 0.9 if you don't mind. Well, that's negative 10. So let's take a number that's a little bit closer. Remember, I think that as we get really, really close to really close to 1 from values less than 1, we're going to get to negative infinity. Right now we're only at negative 10. So let's just get closer. So let's take f of 0.99. 0.99 is still less than 1 because we're looking at values less than 1, but still very close to 1, right? As a matter of fact, closer to 1, right? Negative 100. Let's get crazy close, all right? So let's remember, we have to get this right here says values less than 1, so let's do that. Values less than 1, like f of 0.99999. So now we're exceptionally close, aren't we? We're exceptionally close to 1, but not at 1. And look at this. Now we have negative 100,000. Okay? So if you could picture that, where this is our numeric proof that the limit of f of x as x approaches 1 from values less than 1 is negative infinity. Let's try it the other way. So let's ask our calculator the question, what if we approach from the other side? What if we approach from values greater than 1? So we'll ask our calculator that question. We'll go here. With you, that's your menu button. Go to calculus, go to limit. I'm going to take the limit of x as x goes to 1, right? But this time we're going to go from values greater than 1 of f of x. And look, that's positive infinity. So if we go from values greater than 1, we get positive infinity. If we go from values less than 1, we get to negative infinity. Let's prove that, if you don't mind. We're going to do the same thing we did before. We're going to start with some number close to 1, but in this case greater than. So f of, how about 1.1? That's greater than 1, but close to 1. And there's 10. See a pattern here? What if we take f of 1.11? Oops, sorry. That's crazy talk. That's not closer, is it? 0.1. That's closer, isn't it? That's really close to 1, isn't it? And there's 100. What if we do this? What if we take f of 1.00001? See my point here? And there's that huge number. And if you want to know why that's true, look, if we go here, if we have values less, then we'll have some number less than 1 minus 1. It's going to give us a negative at the bottom, isn't it? If we go from some value greater than 1 but near 1, we're going to have a number greater than 1 minus 1. It's going to give us a positive at the bottom. So that's why it's going in those different directions. All right. I hope this was helpful. Let's take a look at the picture. Want to? Graph. And we're just going to graph f of x. And we already saved that thing, so we just type it in as f of x. And then, and there it is. All right. So there's our geographical, our graphical proof of that thing. I want to leave you with two things. One is a favor to you, and one is a favor to me. The favor to you is for you to remember that infinite limits are not the same as limits at infinity. Limits at infinity are in behavior. This is in behavior as you go this way or as you go this way. Infinite limits are where you approach an x value and the height of your function dives towards negative infinity or soars towards positive infinity. So say it with me. Infinite limits are not the same as limits at infinity. Different idea. Favor you can do for me, the little nice thing you could do for me is you could consider subscribing to my channel. Thanks, and I appreciate all the cool comments. I do. Thanks.